Good morning, class. We'll continue our chapter that is organic chemistry, some basic concepts and techniques. So yesterday we have done about the introduction part of carbon containing compounds, and I've explained you the classification of organic compounds. We know that organic compounds have been divided into two parts. One is acyclic, known as open chain compounds, and second is the cyclic or known as closed chain compounds. And further, the closed chain compounds have been divided into homocyclic and heterocyclic compounds. And homocyclic compounds further divided into acyclic and aromatic, and further aromatic has been divided into benzoate and non-benzoate compounds. So yesterday I have dealt with this type of a flow chart. I have shown the flow chart in my last uh, minute of the video, right? Now I'll continue with this only. First of all, I'll take acyclic or open chain compounds. These compounds are known as aliphatic compounds, students. It means they may be single or a branch chain compounds. For example, ethane, isobutane. Isobutane is a common name. Otherwise, you can write down 2-methyl propane. Acetaldehyde known to be ethanol, and acetic acid known as ethanoic acid, right? These are just given the common names. You must know about the common names also. And but in your syllabus you have only IUPAC naming. So my focus is on acyclic, means open chain compounds. Open chain compounds are those compounds which have state or branch chain compounds, students, right? The second one, which I'm talking about, the aromatic compounds. Aromatic compounds are the special types of or ring containing compounds, special type of compounds. It includes both benzoid and non-benzoid. So benzoid means if the main constituent is benzene ring, right? If in a chain of carbon atoms there is a benzene ring, especially main as a main constituent, that is called benzoid aromatic compounds. And other than that is known as non-benzoid compounds. So I have given the example to you, like benzene, aniline, naphthalene, anthracene. These are the examples of benzoid aromatic compounds. And non-benzoid aromatic compound means other than the benzene ring, if any ring is present, such as propanol, जिसमें हमारे पास 6 मेंबर्ड की जगह यहाँ पे 8 है, 1 2 3 4 5 6 7 कार्बन एटम्स हैं हमारे पास, right? Or it may be an 8 कार्बन एटम ring, right? So these are known as aromatic compounds, and these are special type of compounds, students. These are also known as heterocyclic aromatic compounds, right? Like acyclic compounds. So heterocyclic aromatic compounds is the another type which I'm talking about. One is like furane, thiophene, pyridine. This class is known as another class of aromatic compounds known as heterocyclic. Heterocyclic means other elements are also present in the ring along with the carbon atom. Suppose oxygen is present, if along with the carbon atoms, it is known as furane. And if sulfur is also present along with the ring, along with the carbon atom in a ring, it is known to be thiophene. And if nitrogen is present, it is known as pyridine, right? Now, you know about the functional group, students. What is a functional group? A functional group may be defined as an atom or a group of atoms joined in a specific manner, right? Which have a different characteristic properties such as alcohols, such as aldehyde, ketones, carboxylic acid, right? Ethers, esters, amides. We have a different class where we have a different class of these groups, and some of them you have done in the class 10th also. As you people know about the homologous series also, students. Homologous series is a group of series of organic compound, each containing a characteristic functional group, and forms a homologous series, right? For example, if there is a formula, I'm talking about alkane. So two alkanes differ with the help of CH2 unit. It means they are homologous series, right? They all are homolog. Some of these are alkanes, alkenes, alkynes, haloalkanes, alkanols, alkanols, alkanones, alkanoic acid, amines. These all belongs to homologous series. Suppose the question come, what is the homologous next homologous member of propane? So that is butane. and both propane and butane differ with only CH2 group, right? Now, you must know that what is the CH2 group, what is the CH3 group, students. So I'll start with the nomenclature, and you know that a compound has a two names. So systematically, we use a IUPAC name, and the second is common name. But in your syllabus, we have only IUPAC name, nomenclature, International Union of Pure and Applied Chemistry System of Nomenclature. And these names are correlated with the structure such that the reader or the listener can deduce the structure from the name. That is commercially used, internationally used. So my first example is the IUPAC system of nomenclature is that suppose we have a carbon chain. This long chain of carbon is known as a parent chain, and a group is representing. Along with that, one Br is there, one CH3 is there, one OH is there. Now, what is this Br? What is this OH? These are known as functional groups. Other than the carbon chain, whatever the atom is present is known as a functional group. And if in a main chain some branches are there, that is known as substituent. Suppose this is a chain and one branch is being represented, that is one group is being represented here. This is known as a substituent or a branch, right? So you can clearly see that a long carbon chain which is being selected is known as a parent chain, and other than the carbon atoms, the groups are known as functional group. And if there is a main chain and the branches of chains are there, that is called branch or substituents. Now hydrocarbon means the compound containing carbon and hydrogen only, students, right? So we'll start our next topic, that is the nomenclature of alkanes. As you people know, students, alkanes, general formula of alkanes is CnH2n plus 2, and the suffix we use for the alkane is ane, right? And prefix containing the number of carbon atoms. And today we have discussed about the word root, right? How many number of carbon atom present in a chain. If one atom is present, we use the word meth. If two carbon atoms are present, then it. Three carbon atoms, we use prop. For four, but. For five, pent. Six ke liye hex, seven ke liye hept, eight ke liye oct, nine ke liye non, and 10 ke liye dec. We have to learn till 10 only. And if single bond is present in a chain, if a carbon chain is there and carbon atoms are linked with a single bond, it is known as an alkane chain, and we use a suffix for that, that is ane, and the name will be then ethane, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, right? So these will be the names as you people know about it. This is nothing new, just we are recalling our previous concepts. Now, same with that, we have a branch chain hydrocarbons also. If main chain is there and some other chains are attached with it, other carbon atoms are attached on the branches, they are known as branch chain hydrocarbons. Small chains of carbon atoms are being attached at the more at one or more carbon atoms of the parent chain. They are known as small groups, substituents, or branches. So one of the example is like CH3, CH, CH2, CH3, and one branch is being given here downstairs, and this is known as a group, substituent, right? This is not a functional group. This is just a side group, or this is known as a branch or a alkyl group, right? And we have to count, first of all, if we have to do the naming, we'll select a carbon chain having a maximum number of carbon atoms. We'll select that. So we'll name that chain, and before that we'll name the name of substituent which is being attached to it, on which position it is being attached. So here the name of this compound is 2-methyl butane. Similarly, we have more than two branches. So how we will name that compound? Will name alphabetically wise. If one ethyl group is there and one methyl group is there, so we'll use ethyl first of all. Why? Because E comes up first and methyl comes after ethyl, right? We'll use alphabetically. In order to name such compounds, the name of alkyl group are prefixed to the name of parent alkane. An alkyl group is derived from a saturated hydrocarbons by removing a hydrogen atom from carbon. From where does these alkyl groups come? Only from the methane part. If one of the hydrogen atom is being removed, it become an alkyl group, that is called methyl group. Similarly, we have ethyl, methyl, propyl, different types of alkyl groups. You can see we have, for CH3 we use methyl if it is present as a substituent in the chain, and if CH2 CH3 group is present, it is known as ethyl. If 3 carbon atoms present in a branch, that is known to be propyl. Similarly for butyl, and similarly for decyl, right? Now, to name a chain, what concept should be in mind? First of all, we'll select the longest chain containing maximum number of carbon atoms, right? Suppose this is a chain, it is being given here, an alkane chain, and here how we can select, we have to see the chain in which maximum number of carbons appear, right? So suppose I have taken this straight chain, here we have 9 carbon atoms. Now the three groups are two groups are left, which is known as alkyl groups. One is this methyl group, and the second one is, which is on the 6th position, that is ethyl group. Now how to name this? Now here we have two substituents left, one is methyl and the another is ethyl, so we'll use the alphabetically order. If E comes first, right? So the name of this compound will be 6 ethyl 2 methyl, right? 6 ethyl 2 methyl nonene. It should be like that. So how? First of all, we have counted the numbering is done. Now, from where we have to start the numbering? We have done this, that we have two types of substituent, और दो टाइप के substituent में हमें देखना है alphabetically कौन सा पहले आ रहा है. तो ethyl पहले आता है, E पहले आता है, तो मैंने वो select कर लिया कि E पहले आता है. But the same time, I have to see that from where we have to start counting the carbon atoms. Either I can start from the left hand side, or either I have to count from the right hand side. So where we have to start? So from that side we will start, from where my substituent will get our lowest number, right? If I'll start from the right hand side, I would have not get, my substituent would have not get the lowest number. So we will start the numbering from that side, from where the branch carbon atom get the lowest possible number, student. If I'll start from the left hand side, the sum will be 2 and 6, right? It will be a lowest sum. And when I start with this side, right hand side, the sum would be more. So I'll start with, in such a way, I'll do the numbering in such a way that the branch carbon atom would get the lowest possible number. And if two different alkyl groups are present, so alphabetically we'll arrange it, right? So if two or more identical, this I'm talking about, if two or more identical substituent groups are present, then the numbers are separated by commas, right? Suppose दो same alkyl group हमारे पास present है इस chain में, एक second position पे methyl है, एक fourth position पे methyl है, both are methyl groups. Now what to do? We'll name the both of them, but we'll use a comma between them. 2, 4 dimethyl, we use word di. If 3 are there, then trimethyl would be there, right? And the names of identical substituents are not repeated. Instead, prefix should be used. Di, tri, tetra, penta, hexa, they should be used, right? Along with the position. If two substituents are found in an equivalent position, students, right? So we'll prefer where the lowest number is given to the one coming in a alphabetically order, like in this case 1,3-dimethyl butyl, right? It should be like this, because here the lowest number is given to the one coming first in alphabetically order. The branch alkyl chain can be named by following above mentioned procedures, and the carbon atom of the branch that attached to the root alkane is numbered 1, right? As you can see here. Thank you very much. We'll do more problems. I'll discuss with you in my doubt session. Thank you very much, students.